In this video, we're going to look at the waveforms of a buck converter operating open loop. So there's no feedback. We're just driving a particular duty cycle and looking at the switch voltage waveforms and the current. So here is a PWM signal. I'm just generating that with a signal generator to give us a known duty cycle. This is the switch voltage, the junction of the two MOSFETs and the inductor. So it's switching between the return, the common, and the supply voltage. And this is the inductor current. So we see that when the switch node voltage is high, that is the upper switch is on, the lower switch is off, the current is ramping up in the inductor. Because we have positive volt seconds, the difference between the input and the output voltage, which is this blue line here, okay, is positive. So we're applying positive volt seconds. Here, because the output during the off time, the lower switch is on, the top switch is off, we're applying just the output voltage, but negative, so we're applying negative volt seconds and we're driving the current down. So let's see what happens as the duty cycle is varied. First thing we notice is that the duty cycle increases, so does the output voltage. And that's what that's the prediction. The output is a duty cycle times the input. You know, the input's constant around 12 volts. So as we increase the duty cycle, the input voltage is going up. And if we do the math down at the bottom, here is 60% duty cycle times 12 volts, about 7.2 volts. Now 70% duty cycle times 12 volts, 8.4 volts. So we see that the math follows. Here we are all the way at about 80% duty cycle, 9.6 volts output. All the way to now 90%, about 10.8 volts output. So in this case, the load current is being held constant. The load is a constant current load, and that's why the load's not changing with the output voltage. So now again reducing the duty cycle, and the output voltage is also reducing. Here, I'm lowering the input voltage while keeping the duty cycle constant. And you'll see that the output voltage is decreasing proportionately. So yes, output is duty cycle times the input. Here the duty cycle is constant, the input voltage is changing. And as I lower the input voltage, the output voltage decreases in proportion. So here we got 50% duty cycle, 6 volts in and about 3 volts out. Increasing the input voltage, we're still keeping that constant 50% duty cycle. We get back to 12 volts in and we have about 6 volts out. Here, I'm changing the load current while keeping the duty cycle and the input voltage constant. So you see that the output voltage does not change. I'm changing the output current, the average output current. It's going up, goes down, but the output voltage remains constant. And that's because, again, there's no term for output current here. The output voltage is duty cycle times input. So even if I change the output current, then the voltage doesn't change. Now I'm back to changing the duty cycle. Changing the input, just to kind of review what we saw before. And change the current, no change in the output, as long as the input and duty cycle are the same.